Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is integrals. In this video, we'll be focusing on NCERT solutions for exercise number 6. In the first problem, we need to find the integral of x sin x dx. Now we see there are two functions here, x and sin x. We know by parts. We just repeat that formula which we have discussed in previous video, that if you have function like f of x and gx, then its integration is given by first function into integral of second function minus differentiation of first function into integral of second function. So this formula will be using here, but a question comes which to be used first, whether this algebraic function or the trigonometric function. There is a rule for that, we call it as Eilert rule, in which if inverse trigonometric is there, that will be taken as first function, then preference is given for logarithmic function, then algebraic, then trigonometric, and finally exponential. So we have a algebraic function x and a trigonometric function as a second. So which one we should take? So first is algebraic. So we'll take x as the first function and sin x as the second function. So we'll proceed now. We'll write x sin x dx equal to first function x into integral of second function. Sin x integral is minus cos x minus, we put minus here, integral symbol, differentiation of first function. So differentiation of x is 1 into integral of the second function, which is minus cos x dx. So this will be minus x cos x. What is the integral of cos x? Is sin x itself. So plus sin x plus c. So this is the final answer. Now in this problem we need to integrate x square ex dx. So again, from the previous example, first we have an algebraic function, then an exponent function. So we use the formula Eilert. So algebraic is coming first and exponential coming second. So we'll treat x square as first function and e power x as the second function. So we can write this x square e power x dx equal to first function into integral of second. Integral of ex is ex itself minus differentiation of first function 2x into integral of the second function, which is e power x itself. So this will be x square ex minus 2 x e power x dx. So we can again proceed x e power x in the same fashion as first function into second function. So we can write this x square e power x minus 2. So first function into, this is first function into integral of second, which is e power x minus differentiation of first function, which is 1 into integral of the second function, which is e power x dx. So we'll x square e power x minus 2x e power x. What is integral of e power x? Is e power x itself minus e power x plus c. So this is the constant of integration. We'll add 2 also should be coming here. Yeah. So we can take e power x common. So x square minus 2x. Here minus minus, this will be plus 2 plus c. So this is the final answer. So in this problem we need to evaluate x log x dx. Now the question comes, which function should be taken first, log x or x? So we use the principle Eilert. Here we have algebraic function and a log function. So log function is coming first. So we'll take log as the first function. So we can write this as log x into x dx equal to first function into integral of second. So First function is log x into integral of that x square by 2 minus differentiation of first function. So log x differentiation is 1 over x into integral of x is x square by 2 dx. So we can cut this. So this will be x square by 2 log x minus integral half x dx. So this will be x square by 2 log x minus half x square by 2 plus c. So we can simplify this. Further, equal to x square by 2 log x minus x square by 4 plus c. This is the final answer. Now in this problem we have a algebraic function and a trigonometric function. So again we can use the Euler principle. Inverse function should be taken as first and algebraic should be taken as the next. But there is a simpler approach. By using this principle, if we take by parts, if we use this formula like first function into integral of second minus differentiation of first integral of second, becomes more complicated when we use inverse trigonometric function. So we put a simpler approach here. I will teach you that. We'll put x equal to sine theta. So dx will be equal to cos theta d theta. So this integral will be x is sine theta. So sine inverse sine theta. We are substituting back here as x equal to sine theta. Then dx will be cos theta d theta. So this will become theta and we have a sine theta cos theta. So that can be written as half integral. So we are writing this as 2 sine theta cos theta. So we are dividing by half. So theta sine 2 theta d theta. Now this is much easier to solve than the inverse. So this is algebraic and this is trigonometric. So we can easily solve it. So we'll use it, that principle equal to half first function into integral of second function. So theta into minus cos 2 theta by 2 minus integral differentiation of theta is 1 to minus cos 2 theta by 2 d theta. This will be minus theta cos 2 theta by 4. What is the integral of cos 2 theta is sine 2 theta divided by another 2 will come. So 2 into 2 4 and here 2 is there 8. So this will be plus sine 2 theta by 8 plus c. Just let us cross check it whether all thing is okay. Yeah. So but cos 2 theta, we want everything in terms of sine theta because we want to make a substitution x there. So this will be written as minus theta 1 minus 2 sine square theta by 4 plus 2 sine theta cos theta by 8 plus c. Why we are writing everything in terms of sine theta? Because we want to make a substitution with sine theta with x. So now we'll do it. Minus theta is sine inverse x into 1 minus 2 sine square theta 1 minus 2x square by 4. So this 2 sine theta here it will get 4. So plus sine theta is x. Cos theta can be written as 1 minus sine square theta divided by 4 plus c. So this is the final answer. In this problem, we need to evaluate sine inverse x the whole square dx. So we will put sine inverse x equal to theta implies sine x equal to sine theta equal to x. So we can write this as cos theta d theta equal to dx. So we'll make substitution dx with cos theta d theta. So this will be equal to theta square cos theta d theta. So now again we can use by parts. Theta can be treated as an algebraic and cos theta is trigonometric. So theta square will be taken as the first function. So we'll do it. First function into integral of second function, which is sine theta, minus integral differentiation of first function into integral of second function d theta. This we have to evaluate once more. We will write is theta square sine theta minus 2. So first function into integral of second. So theta into minus cos theta minus integral differentiation of first function into integral of second, which is minus cos theta d theta equal to theta square sine theta minus, we will expand this, so this will become 2 theta cos theta, and this is minus minus is plus and one more minus, so one minus will be coming, minus, and integral of cos theta is sine theta minus 2 sine theta plus constant of integration we can add. Now we'll put back theta equal to sine inverse x, so we can write the final answer as sine inverse x the whole square. We are writing theta as sine inverse x into sine theta. Sine theta is x into x plus 2 sine inverse x. Cos theta is square root of 1 minus x square. When sine theta is x, cos theta will be square root of 1 minus x square minus 2x plus c. So this is the final answer. So in this problem, we need to find this. Before we explain how to solve this, there is a one very important formula which student must remember. That is, if we have an exponential function e power x, and if you are multiplying with f of x plus f dash x, another function whose function plus derivative is given, then its answer is e power x f of x plus c. So we'll be using this formula in this. So how do we use it? Let us see. So this can be written as e power x plus 1 minus 1 we have written divided by 1 plus x square the whole square dx equal to, so this can be simplified into two partial fractions, so we can write it this as e power x, so x plus 1 divided by 1 plus, so 1 plus x the whole square will be 1 plus x, and this will be minus 1 over 1 plus x the whole square dx. Now we come back to this formula. If we take this as f of x, then this is the derivative of that, and we are multiplying with the exponential function, so we can directly write the answer as this. So answer will be e power x 1 by 1 plus x plus c. This is the answer. This is an MCQ question where we substitute x cube equal to t. So this will implies 3x square dx equal to dt. So we substitute x square dx as 1 by 3 dt. So we can write this x square e power x cube dx equal to x square dx is written as 1 over 3 dt, and this is e power t dt equal to 1 by 3 e power t plus c. This is the integral of e power t is e power t itself. You put t equal to x cube, 1 by 3 e power x cube plus c. So let us check which one is correct. Option A is correct. So again we see in this problem we have an exponential function plus another function. So we write this as e power x. We multiply sec x into 1, which is sec x plus sec x tan x dx. We have seen earlier, if an exponential function is multiplying a function plus its derivative, then the result is e power x sec x plus c. This is the answer. We are using that formula. E power x, we will write again. E power x f of x plus f dash x integral dx will be equal to e power x f of x plus c. So we are using that formula. This is f of x sec x. Its derivative is sec x tan x and it is being multiplied by exponential function. So the answer will be e power x f of x plus c. So e power x into sec x plus c. This is the answer. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.